Hello and welcome to this IB Math Standard Level video. I'm going to be talking about how to add vectors, vector arithmetic, and essentially how we do operations in this realm. So how do we do it? Well, first of all, we have to define what do add vectors mean. So this is what adding vectors mean. You take a vector u, for example, one step right, one forward, vector v, 2 steps forward, one right, and this is how you add them. So you first do vector u, and then from where you get to, you do vector v. And that's what vector u plus v is going to look like. Let's call it vector w. So in both 2 dimensions and 3 dimensions, what you do to add vectors is essentially you're going to add the coordinates. So vector u plus v is going to be the x coordinate of the u and the v added together, the y coordinate of the u and v added together, and so on. That's how it works. Here's an example. So that's what adding vectors is about. So what does this take us to? It takes us to one very important type of vector notation. This is a very useful way to write vectors. Very common, so you have to learn it. So let's take the most simple of vectors. Vector I, vector j, and vector k. The names are important. They're always called the same way. So these vectors would be the following, right? Vector I over here, just one on the x-axis, vector j, one on the y-axis, and vector k, one on the z-axis. So what can I do with these? I can define any vector by adding these 3 vectors together in particular ways. For example, this vector over here could be written, this is vector v, 1, 2, 3, can be written like this. Vector I 1 time, vector j 2 times, and vector k 3 times. And essentially this is what you're doing. This, and then this 2 times, and then 3 times this. And that's one important type of vector notation. How do we subtract vectors? Again, same thing. All you're going to do is add the negative. So for example, in the same way that if I have 2 minus 3, what I'm doing is 2 plus minus 3, I'm going to do the same thing with vectors. So I'm going to add the vector in negative. And what's a negative vector then? Well, it's just a vector that goes in the opposite direction. So what does it mean? For example, if I have u minus v, I'm going to think of it as u plus minus v. And that's essentially u plus minus 1 times v. So of course, minus 1 times v, that's going to be the same vector as vector v, just with everything in negative. So for example, if I have to vector u and v here, and I have to subtract them, what I'm going to be getting is vector 5 minus 3, 3. So parallel vectors. When are 2 vectors going to be parallel? 2 vectors are going to be parallel when they have exactly the same direction, like these ones here. Now, why are they parallel? Well, actually look at them in 3 dimensions. They happen to rely all on the same line. So these are the definition of parallel vectors. Now realize that what's happening here is if I take 2 and I multiply 2 times vector u, I get vector v. And if I multiply minus 1 times vector u, I get vector w. So 2 vectors are parallel if they're scalar multiples of each other. Scalar, remember, is just a number. So these 2 are going to be parallel because if I multiply the first one times 2, I get the second one. And that's how you figure out whether 2 vectors are parallel or not. This is also telling you how, by the way, you multiply numbers and vectors. So just a few more things. A few clarification. What's the difference between a position vector and a point? Well, a position vector is a vector that takes you from the origin to a point. So suppose you're in the origin and you want to go to point P. Here's point P, which is vector 4, 2. The vector that goes from the origin to point P is going to be, well, vector 4, 2. Same thing. It can be confusing to know when are we talking about a point and when are we talking about a position vector. It might be confusing. It doesn't really matter because it's the same thing. The only thing is you have to make sure that you're using the right term to refer to it. Another little trick, midpoints. If you happen to have 2 points, you can figure out the point that lies exactly between them. Between point A and point B, I can figure out exactly the coordinates of point M that's right between A and B. How do I do that? Essentially what you're going to do is you're going to take half of vector OA, which is the vector that goes from the origin to A, and add half of the vector that goes from the origin to B, which would be over here. Remember, I'm just taking half of this one, and I'm going to do half of this movement first do half of the first movement, then do half of the other one, and that's how I get to m. So the way to calculate it, actually I think it's in the formula booklet, simply you do half of vector OA, half of vector OB. So you're going to do half of vector 4, 2, half of vector 2 minus 2. That's going to be, well, 4 divided by 2 is 2, 2 divided by 2 is 1, 2 divided by 2 is 1, minus 2 divided by 2 is minus 1, and so you end up with vector 3, 0. And that's going to be the vector that takes you from the origin to point M. Vector 3, 0 indeed takes you from the origin to point M. And that's how you can calculate the midpoint, or between the point that's in the middle of 2 points. And you actually have a formula that looks a little bit like this in your formula booklet. So what else are we going to be doing? That really is pretty much it in terms of vector arithmetic. There's one important thing. We know how to add and subtract vectors. We know what parallel vectors are like. We know how to find the points in the middle. We know what position vectors are like. We know how to multiply numbers and vectors. But what about multiplying two vectors? What about perpendicular vectors? And what about the angles between vectors? And most importantly, we know about points, we know about vectors, but what about lines? And this is going to be the second half of the vectors program. The important thing now, the thing that's going to be next, is how to multiply vectors together, something called the scalar product. Thank you very much for watching. See you next time.